Hi Coach L, this is the tutorial for using an LCD screen. Let's go. This is the basic code for using an LCD. We're going to connect an LCD to the Arduino board and display a short message. So first what we're going to do is we're going to use this hashtag include liquid crystal to include the liquid crystal library from Arduino. And we're going to then initialize the library using the pin with the pin we're using the liquid crystal LCD 12, 11, 5, 4, 3, 2. Those are the pins that the board is connected to. And then when we get to avoid setup, we're using the LCD screen with a 2-line, and the LCD screen that we're using has 2 lines of 16 characters each. And so using the LCD.begin 16,2, it's defining for the library that is the size and type of LCD screen that we're using. So 16 characters and 2 lines. And then we're going to use the LCD.clear to clear the LCD screen because since the data is sent to the screen, it stays there until it is overwritten or power is removed, so we have to clear it afterwards, so there's no data that's going to be overwritten. Then we're going to use lcd.print, parentheses, hello world, and we're going to use that to print out the message on the LCD screen. And on the LCD screen, there's a cursor that by default is invisible, and that determines where the data we type will appear. So when the display screen powers up, the cursor starts on the top row or the first column in general. So that's where we're going to print hello world. So there's that. And then when we get to the void loop, we're going to set our cursor to the second line on the first column of that line. And so when we're using this screen, we can set the invisible cursor to any location on the LCD before setting the data. So the counting on the screen starts from 0, so the top line is line 0 and the bottom line is line 1. And the columns range from 0 to 15, not 1 from 16. So the hello world will be printed on the first line. In order to print the next part of data to the next line, we have to use the set lcd.set cursor 0, 1 to set it to the column 0, so the first column, in the second line, line 1. And now we're going to print out the number of seconds passed while it's being turned on, since the Arduino was last reset using the lcd.print milliseconds divided by 1,000. So that means, each second is 1,000 milliseconds, so for every 1,000 milliseconds, it's 1 second. So if it's 2,000, it's 2 seconds, and onwards. So since the new values will always overwrite the previous because because they are bigger, they are larger than the ones before them. So 2 is larger than 1. We don't have to worry about them being having the display leave orphan characters, which happens when the new value is shorter than the old one. So, but if we were to display a varying number or decreasing numbers, we'll have to make sure to erase the old number using this code here before writing a new. This is an example of code that we could use before writing a new number. And since as long as we erase the old number immediately before we print the next number, the momentary erase won't be noticeable. So that's it for that. Here's the basic board setup for using the LCD. So here we have the LCD screen, and there's 16 inputs here, input pins here. So the first pin right here is going to connect ground. Is going to ground it using this black wire, and the symbol for that pin is VSS. The next pin here is the symbol is VDD, and it's a power supply input for the driver IC, and that's going to connect the board through this white wire here to 3.3 volts using this red wire to the 3.3 volts on the board over here. Then we're going to go to the next, which is the third pin, which is the symbol for that is V0, and that's the LCD operation voltage test pin, and that's connected through this orange wire, which is kind of hard to see, this orange wire here, and that's connected to this potentiometer down here. We'll get to that in a bit. The next thing is this yellow wire here, which connects the fourth pin on the board to the data and control register select pin. H is for D0 to D7 core display data, and LD0 to D7 are control data. So that's what the yellow pin connects it to, yellow wire connects it to. The next is this brown wire here, and it's grounding the board again by connecting to this negative column. And pin number 5, which it is connected to, is the right single input for active L. That's what the function for that is. Then we're going to get to this green wire here. That's connected to pin number 6 on the board. And that's the start signal for reading or writing data. So that's connected to pin number 11 on the Arduino board, and the yellow wire is connected to pin number 12. Then we're going to skip next 4 or 5 ones here, and those are just data bus bits from 0 to 3. And then we're going to get to this yellow wire here, which is pin 11 on the board, the LCD board, and that's DB4, which is a data bus bit number 4, and that's connecting the board to pin number 5 on the Arduino. Then this orange wire, which is next, is connecting data bus bit 5 to on the LCD board to pin number 4 on the Arduino. This yellow wire here connects the pin number 13 and data bus bit number 6 to the Arduino board pin number 3 here. And then finally this orange wire here, this one here, connects pin number 14 or data bus bit number 7 to the number 2 pin on the Arduino board. There you go. So then when we get to the potentiometer here, it's connected to the 3.3 volts, this white wire here, to the positive column, which is then connected to this red wire to the 3.3 volts. And then it's grounded by this brown wire, connecting it to the negative column, which is connecting it to this black wire here, which is grounding it to the ground pin. And then this orange wire here connects the LCD board to the potentiometer. And so what the potentiometer is used to is to control the contrast on the LCD board itself. So we can see that if we move this, it'll change the contrast on the board. And so once we've found the contrast that we like, we don't have to change it anymore. It'll go back there every single time. And so then how the LCD screen works is there's a total of 32 possible characters on the board. So that's consisted of 2 rows here, and on each row there's 16 characters, possible 16 characters. And we can see that if we turn the contrast all the way up, that we can see the different boxes that it can contain characters. So yeah. And then the LCD is then controlled through the library that we use on the code. And so that's it working. It says hello world, and it's counting the seconds up for us. There we go. This is the modified code for using an LCD screen. So what we're going to do is we're going to have the LCD screen display different messages depending on the value that the photoresistor measures. Depending on the value of the light, there are going to be different LEDs that will turn on, and the servo motor will turn in different directions. So what we're going to do first is we're going to load the liquid crystal library, and we're also going to include the servo library, so we can use those to command those the LCD screen and the servo motor later. We're also going to create an object using a servo object called servo1. And again, we're going to initialize the library with the pins we're using, and we're going to create a constant integer for the sensor pin for the light sensor is attached to. So it's attached to the analog pin 0. We're also going to set up some global variables for the light level calibration value and the raw light value. So light cal and light value, and then using the constant integer function, we're going to create constant integers for the LEDs. So LED 1 and LED 2 will be attached to pin 8 and pin 7. Then we're going to get to void setup, and we're going to take a single reading from the light sensor and store it in the light cal variable using the light cal equals, and using the analog read function for the sensor pin. That's going to give us a preliminary value to compare it against in the loop. We're going to begin the LCD screen at 16 and 2, so that's the size of LCD screen we're using. We're also going to clear out the LCD screen at the beginning. We're going to attach the server 1 to the pin 9 on the Arduino board using a server 1 attach. Then we're going to use the pin mode to set LED 1 and LED 2 as outputs. And then we're going to start the serial port at 9600 using the serial begin function. When we get to void loop, we're going to create a local variable to store the servo's position using integer position. Then we're going to take a reading using the analog read function of the sensor pin and store it as light value. Then we're going to use the serial print function here to print out the light cal equals the value that the light cal is, and then print a spacer out here, and then do the same thing for the light val. Now we're going to use an if statement. So if the light value is, if the light value is greater than our initial reading, which is light cal plus 50, then we're going to have it's going to serial print out that the LCD will be turned on. So the LCD is going to be turned on, and we're going to print out good morning. So in order to do that, we're going to set the cursor at 0, 0. So we're going to set it at column 0 and line 0 using the LCD.setCursor. And then we're going to use LCD.print to print out good morning. Then we're going to print out on the serial monitor that we're printing out good morning. Then we're going to use the LCD set cursor to set it to the first column of the second line. So the first column here and the second line. Then we're going to print out the number of seconds since the Arduino's last reset using LCD print milliseconds divided by 1000. And then we're going to use the digital write function here to set the first LED on high and the second LED on low. We're then going to tell the servo to go 180 degrees by stepping by 2 degrees using this for statement. So if the position equals 0 or it's less than 180, it's going to increase by 2 degrees. And in order to make that happen, we're going to use servo.write position to move it to the next position, and then delay for a short pause so we can allow it to move. And then we're going to print that all out on the serial monitor. So we're going to print out a spacer, and then we're going to do time equals the milliseconds divided by 1000, so the actual time since the last reset, and then print out servo to 180 degrees to tell you that the servo is going to 180 degrees, and then print that the LED 1 is on. Now we're going to do an else if statement here. So if the light value is less than light cal minus 50, so if it's darker than the original value, then we're going to print out that it's going to say good night. So in order to do that, we're going to do serial print the LCD is on. So on the serial monitor, it's going to print that out. We're going to again set the cursor to the first column and the first line. And then we're going to use the LCD print function here to print out good night on the LCD screen. And we're going to then on the serial monitor print out good night. Then we're going to set the cursor to the first column and the second line. So we're going to go to the second line here, and we're going to print out the milliseconds since the last reset, the seconds since the last reset using LCD print. And again, use the digital write function here, but we're going to set the first LED to low and the second LED to high or on. Again, we're going to use this for statement, but we're going to use this for statement to change the directions of the servo. So when the position is 180, and if it's greater than or equal to 0, the position is going to decrease by 2 degrees. And then we're going to move, so in order to make that happen, we're going to use servo.write position. So that's going to move it to the next position, and then we're going to delay for a short pause to allow it to move. Then we're going to print that all out again on the serial monitor. And then so we're going to use the else function here. So if it's neither greater or less than the light, then we're going to use the clear command here to clear the liquid crystal library, to clear the screen so it should be dark. So lcd.clear, and then we're going to use digital write function here to turn off both the LEDs, and then just print out that the LCD screen is off. And here's the serial monitor. See right now, LCD is off, so the light is not greater than or less than. So if we increase the light, it'll tell us good morning and tell us the time and everything. And if we go to good night, and if we go right back to where we want it to, And there we go. And that's it. Back to the normal light. And there we go. Here's the modified board for using an LCD screen. So here we have the LCD screen set up and wired the same way as it was before, except now we have the potentiometer connected to the board by this red wire, not an orange wire. So it's moved up a little bit. And here we have a photoresistor. And so that's going to be, that's going to be attached to the 3.3 volts through this red wire here, and then through this red wire to the 3.3 volts on the Arduino. And then it's going to be connected to the analog pin 0 by this yellow wire here to the analog pin 0. Then it's going to be grounded through this 10,000 ohm resistor here, and then grounded through this gray wire here to the ground, this black wire to the ground pin on the board. Then we go to these LEDs here, and we have both these LEDs are connected by their anodes through these 100 ohm resistor through these white wires to pins 8 and 7. See on the board there. And then they're both grounded by connecting their cathodes to the negative column, and then grounded by this black wire. Then we get to the servo motor here, and then we can see the 3 wires here. It's connected to the pin number 9 on the Arduino board through this white wire. It's grounded by this black wire by connecting directly to the Arduino board, and then by this blue wire, because they ran out of any other color wires, it's connected to the 5.5 volts on the board. So here we have the board. You can see that no light has changed, so the board is not saying anything and the servo motor isn't running and the lights are not on. If we turn up the light, this board will display good morning in the seconds that's passed. The motor will turn to 180 degrees and the first LED will turn on. If we turn the light off, it'll say good night. The servo will now change directions and go to 0 degrees, and the red LED will turn on. You can see. And if we can find where it was before. Yeah, there we have it.